Hello everyone, myself Diksha Gupta from NCA 5th SEM IPS TAVV. Today I am going to solve my first internal test paper set D, and here is a question first which says find the cube root of a 5 using Newton-Raphson method correct up to 4 places of decimal. So let's get started. We know that if we want to find cube root, then we can write it as x cube is equals to 5. We can also write as x cube minus 5 equals to 0. We can write this equation in the form of function which is x cube minus 5. Now we will find the differentiation of this equation x cube minus 5. We know that the formula of differentiation of x to the power n is equals to n n n multiply x to the power x to the power n minus 1. So we can differentiate this formula, and we get the result as 3x squared. The differentiation of 5 as 5 is a constant, so its differentiation is become 0. So we get f dash x is equals to 3x squared. Now we know that the Newton-Raphson formula for the Newton-Raphson iterative formula is xi plus 1 is equals to xi minus fxi divided by f dash of xi. We will going to put all our functions values here. We will get the xi plus 1 equals to 2xi cube plus 5 divided by 3xi square. We know that the cube root of 8 is equals to 2 and cube root of 1 is equals to 1. So our root must be lies between the 1 and 2. Let's assume 5.5 as our initial guess value, and e equals to 0.001. By using this formula, by using this value, this formula, we will find the equation. Now for put I equals to 0, we will get our x1 value, xi plus 1 value as 1.7407, which is not less than e is a precision value which is 0.001. In again, when I equals to 1, we will find x2 means xi plus 1. I is 1, so it become x2. So this is 1.7105, which is again false. In x3 means third iteration, it will become 1.7100, which is true. Means we will get the cube root of 5 is 1.7100. So this is our first question, in which we have to find cube root using a Newton-Raphson method. Now moving to the next question, which says write an algorithm for finding the square root of 5 using fixed point iteration method. So let's get started. In first step, we used to read x0, e, and n from the user. X0 is the initial guess value, e is the precision value, and n is the total number of iterations to be allowed for convergence. In second step, we used to initialize gx0 in the x1. Now we used to we in third step we initialize for loop equals to 1 up to n incremented by 1. In fourth step, we used to assign x1 in x0. Ultimately, we are assigning g of x0 in x0. Now again, we are assigning g of x0 in x1. Means we are assigning g x0 value is g of x0. Means we are assigning g of x0 in x1, and we are checking this condition. If it's true, then we move to the step number 9 and say we find our convergence root, and we will stop the algorithm here. If we suppose our loop iterate n times, and until our loop iterate n times, and but our condition is always but our condition will remain false. Will Then we will move to the step 7, and we will say that we do not get our roots and our algorithm will be stopped here. So this is a fixed point iteration method for finding the square root of 5. Now moving to the next question. Third question, give the output of Gauss-Seidel algorithm for this matrices. Gauss-Seidel algorithm is a method for solving a system of simultaneous equation. It is an iterative method. It is an iterative method in which we used to find the values using the iterations. we will rewrite this matrices in the form of equation, and below we can see that these are the equation which we'll get from this matrices. Now using first, second, fourth equation, we will find the value of x, y, z. As you can see here, we will find the value. We will shift all the values to the right hand side, and we will get the value of x. Now now in in first iteration, or we can in initial phase, we initialize x, y, z. Okay, okay, is equals to 0. Now for the in the first iteration, we will find the value of x1, and now x1. What we have to do in Gauss seidel method, we will use the updated value, not a previous value. Like in this for solving the y, for getting the value of y, we will use the value which will get as 0. We will use the updated value of x, not previous value. Means we will not put the x value here as 0. We will put the 0.600 as a x, in this at x, in at x. This is so we will find the same manner, we will do this for z and k. We will find this all the value for first iteration, similar way say in second iteration, in similar manner for third and for fourth iteration. And when we get the two values same, when we get a value which is less than a precision value, then we will stop our iteration here, and say we will get our value x, y, z, and k values in the fourth iteration. So this is our Gauss seidel algorithm, where we used where we will use updated values of the x, y, z, or k for finding the next value, not a previous value like in Jacobi method. So this is our Gauss seidel algorithm. Thank you for watching the video.